We have evolved a lot when we talk about from traditional servers or computers that were packed inside a black box inside one room to a API where we can just go and say, I want an EC2 instance from Amazon. The things have evolved a lot. And now with building IDPs, you can just say, I want a Kubernetes cluster internally within a team, and you will be able to get that. So with this evolution from the rooms to the servers to the virtualization to cloud to containers, we have evolved a lot. And with this evolution, there is one thing that keeps on getting increased is the attack surface. So yes, along with this amazing evolution on how we deploy the software, how the software actually goes from a producer to a consumer, the whole attack surface have increased a lot as well. Now, with the rise of open source, most of the applications, like 80-90% of the applications, are actually written or consuming open source softwares. Like all the applications that you are building or providing to your customers, whether it's Spotify, whether it's Zomato, whether it's whatever that you are using in your countries, they are built on top of the open source ecosystem or deployed on infrastructure that uses Kubernetes. So directly, indirectly, you are using the open source software for building your applications. Now, what that means is there is a piece of software that might be written by a single person or a group of person, and you are using that. That is actually the piece of your software too that you are building on top of that. And those softwares also use some of the libraries, some of the dependencies, and there is a whole layering of the stack. Now it becomes very interesting because the attackers can now actually attack these open source, small open source softwares that you are using in your big enterprise application. And if the open source software is detected with a CVE or is becoming vulnerable, then your main application that is linked down deep within the ecosystem also becomes vulnerable and open to attack. So what that means is the whole software supply chain becomes vulnerable. So let's try to understand what SBOMs mean over here. So SBOMs stand for software bills of material. Pretty simple from the naming itself that when a producer is producing the code, it is very important and lawful these days to create those bills of material. That means you need to have what all libraries, dependencies, from where it is coming, who has written the code, all the important metadata about the software is captured before you even release that software. So from the producer side of things, it becomes critical to release those SBOM information while they are releasing the artifacts. And from the consumer side of things, it becomes very critical to read, analyze, monitor in a continuous way to understand what are vulnerabilities, or if there are any vulnerabilities, licenses that got expired or licenses that got changed, there are no impact on the software that they are using. Let's understand it from a different view. It's a very common analogy that everyone gives because it's easily digestible in your brains. So what that means is when you see a food item and when you turn it back, or sometimes on the front as well, when you turn it back, you'll be able to find the list of ingredients, like what all this particular packet is made up of. Now, as a consumer, it's your responsibility to read the information that is written on the back of the packet that you are purchasing, because that gives you the information that whether anything it contains that you have an allergy from, so you can avoid eating that particular piece. Similar to that, the software bills of material, SBOM related to a software, means that it has the information of the ingredients, where it is coming from, what all is went inside this particular software, libraries, dependencies, and all that stuff, so that you get the good dependency tree graph and you are able to understand that what you are actually using within your software, so that if anything is wrong, you can avoid using that particular piece of software. So, the three key things that we say is, like, who's building the software is very critical to understand. What's being built is very critical to understand. And also, when we go a bit higher up, like, the salsa levels or attestations and all that stuff, it's very important where this software is being built. If the build system itself is compromised and the software that you will be using is also tampered and compromised. So there are a lot of things, a lot of moving pieces. I'll link to a few of them, detailed talks that we did recently at Source Community Days in the description of the video. because it's important to understand about zero CVE based images. The images that you are using do not contain any CV or minimal CVs. How you actually can create those minimal base CV images using the software tooling like build safe. So all those things are pretty important. I'll not cover in this particular video, because in this particular video I just wanted to give you a gist of what a SBOM is, why supply chain security is important. And now from CKS perspective, Certified Kubernetes Specialty perspective, there is SBOM which has been added. So let's try to understand and do some of the scenarios from SBOM. So I'm using Ubuntu 24.04 Playground in this particular video to do some of the demos. And one of the things, two tools that you should be aware of, and because we'll be covering two main scenarios in this particular video. One is the SBOM and how to deal with that. And also, since we'll be covering another tool, I'll also be talking about image scanning. So one of the tool which is there is BOM Kubernetes. It is a utility to generate SPDX compliant bill of material. Coming to that, just want to give you a bit introduction or a bit gotcha over here is that there are different formats of SBOMs as well that are created. Like Sift have their own SBOM. There is CycloneDX, there is SPDX. Those are different format in which people publish their SBOMs. It's similar to like you have images, but you have PNG, you have SVG, and you have all these, but your system can actually read that. Similar to that, there's a project in OpenSSF called ProtoBOM. So it says that no matter what SBOM there is, we'll be able to consume that or read that. But it's a simple utility that generates the SPDX compliant bill of materials. It has different commands created as part of project to create SBOM for the Kubernetes project. So let's do that. So let's take a scenario. Maybe in this particular scenario, we want to create a SPDX SBOM for controller manager image. So first we'll install the BOM CLI. So that is this. So wget, getting it from the latest release and then moving that to user local bin. BOM is now installed. You can see we can use the BOM generate command to generate the SBOM. So after this, what we are trying to do over here is we are trying to generate SBOM. So which is BOM generate SPDX JSON and -- image. Give the image registry.io kube controller manager 132.0 and output as in the current directory sbom1.json. The next thing that we want to do is we want to use another tool called Trivy. So I think you won't need to install these tools. Like you won't need to remember that. You will also have the access to the documentation for these, but I think the tools will already be there and you will just be able to generate or visualize or scan and all these things for the SBOMs. So the SBOM is generated. You can see SBOM1 cat, and that's the SBOM related to the controller manager. We can also do a sudo apt get install jq, because the next ones we'll be creating in JSON format. So the next tool that we want to install is Trivy. So let's copy this, the curl, getting the Trivy's latest version, moving that to bin. So Trivy, okay, we have Trivy. So with Trivy also, you will be able to generate SBOMs. And how you can do that is Trivy image -- format CycloneDX, because we need this particular case. If we are saying that we need the SBOM in CycloneDX format, output as JSON and registry k8s.io kube controller manager v132.0. So it has created that cat SBOM2. You can see all the stuff which is there. For example, you have Kubernetes and all. It depends on all these. So it will have all the information for the packages and the libraries and the dependencies that is being used. We can also have cat of SBOM2 and pipe it to JQ to visualize it in a better way. So the next thing that we'll be doing is use Trivy to actually check the results. Like if there is already a SBOM available, then how do you do that? So we'll use the SBOM1, the SPDX format one. So Trivy SBOM and pass the SBOM and then format as JSON and give that particular thing as the output. So if we use this cat and pipe it to JQ, we'll be able to see a beautified version of that. And if you remember, the command that we used earlier was Trivy image. So we use Trivy image to generate the SBOM from the image. We use Trivy SBOM to read the SBOM information. Let's actually read from the second one as well, SBOM 2, and put that in results 2. And now check the result 2. And you can see this one has even more information, like, all the references, the CVE scoring. Okay, it has the CVE scoring as well. So you can see the title, description, all these. If you need to see that in the tabular form, you can just give this and it will give you the CVE information attached to this particular image. Now we want to go a step further. So in Kubernetes CKS certification, SBOM was the latest added topic for the certification, and we have covered BOM and Trivy for that. But since we are already talking about Trivy, and Trivy was also having its use in the image scanning part of it. So Trivy is also used to give the outputs and scan the images, container images, and give out the vulnerability after checking its vulnerability database. So that was already part of the CKS certification exam. So let's do that example as well. So let's say, for example, you have 3 particular pods that you need to create with Nginx, HTTPD, and Alpine images. And then you have to find the images and scan these images and find which images are associated to critical or high vulnerabilities, and then put that inside a particular file, the name of the pods. So for that, obviously, we need a Kubernetes cluster playground. So I have already created a Kubernetes cluster playground. You can go to the playgrounds and just create that. So kubectl gets nodes. We'll create 3 deployments. So let's run these. So kubectl run P1, Nginx, P2, HTTPD, Alpine as P3. And now we need to get the names. So that's the simple command with JSON path. I told you should be comfortable with JSON path. If you have already cleared CKA, you already know about JSON path and stuff. Why this? Because this gives me a easy way to remember, like P1 is associated with Nginx, P2 is associated with HTTPD, P3 is associated with Alpine. Now we can use Trivy, but we installed Trivy on Ubuntu Playground, not the Kubernetes Playground. So we again need to install Trivy. So let's install that, copy this. So it's installing Trivy. Trivy is installed. Now we can just use these commands. Trivy image severity, high, critical, Nginx. So basically we want to scan a particular image and we are specifying the severity level that the vulnerabilities we are concerned with. So for this particular thing, we just want high and critical. We can actually go for critical based on what is asked. So let's wait till it downloads the initial DB for the first scan. So we can see that there is a critical vulnerabilities. Actually, there are 2. So you can see there are 2 critical vulnerabilities. Let's do that for HTTPD. And there is again 1 critical vulnerabilities. Let's do that for Alpine, ALPINE. And there are no vulnerabilities. So as per the scenario that I just illustrated, you just need to put the names of the pod, which is P1 and P2, and not the P3, because P3 is Alpine, P3 is fine. So this type of scenarios are also common with respect to image scanning. But the thing that you have to take care and you have to think is how to do the image scanning using Trivy. So you will be having the documentation for both Trivy and BOM accessible. You will be having the tools installed as well. You need to know how to generate SBOMs using Trivy and the BOM CLI, which I have explained in both the scenarios. One last thing that I want to show is a kind of thing that you should be doing in your regular day-to-day CI/CD pipelines. So I have created this particular workflow in CKS certification. I'll put the link in the description. So in .GitHub workflows SBOM pipeline. So what it does is it generates SBOM on the push to the main branch. The jobs that it runs is Ubuntu latest, checks out the code, installs Trivy, run the same command of Trivy image, produce the CycloneDX format, and output it as SBOM GitHub SHA, associate that name to it and image. Then also upload it as the artifact. So let's kind of see if we can trigger this scan, git add, git commit, new demo, and git push origin master main. So with the push to main, it should start a particular action. You can see the new demo action has been started already on the SBOM pipeline YAML file. So it is starting a job is requested. So code is checked out, Trivy installation, and upload the SBOM artifact. So everything is done. And if we go to actions, we go to this, we'll be able to see artifact associated. Let's click here and we can see below the artifact is there. Let's download that particular file. It will be a zip file which is there. So it is SBOM1, save. Let me unzip that. So we should be able to see cat users, downloads. That's the file. And you can see this is for Kubernetes API server and it's SBOM related information. So this is something that I recommend you checking out. Like, wanted to show because it's important to have SBOM integrated as part of your CI/CD pipelines, and this is how you use it. So in this video, we have talked about key components as part of the CKS certification exam and Kubernetes security spectrum as well. One is SBOM, and two tools that we discussed is the BOM CLI and Trivy, how to use them, both of them to generate SBOMs and also read out the SBOMs using Trivy and get vulnerability information and all that stuff. Another thing that Trivy is used for is image scanning and how you can actually scan the images and find the vulnerabilities associated to that particular images and see if you want to do something with that, like update the deployment or do whatever stuff is needed. And also in the end, we saw how to put SBOMs as part of your GitHub Actions and do it as part of your regular CI/CD pipelines. So that's pretty much it from the CKS perspective, what you need to know about SBOMs and image scanning. So these are the two things that we discussed in this particular video. Thank you so much for watching. I hope you have already subscribed to the playlist of Kubernetes CKS certification. You're sharing that with your friends, and do not forget to press the bell icon and share it again with your friends about this particular video. Thank you so much for watching and see you in the next one.